Unit 6, 2020. Okay. So question number one, a transition metal M has two oxides. One oxide is a black solid and the other one oxide is a black solid. This solid reacts with dilute nitric acid to form a blue solution X. Okay. So it may be copper. You know, copper oxide is a black solid and they are
Yeah.
going to form a blue solution. Tests are carried out on the solution X. Complete the table. So to a 1 centimeter cube of X in a test tube, add a few drops of sodium hydroxide solution followed by an excess. Means that once we are first of all we are going to add few drops and then we are adding X in excess. A pale blue precipitate forms which does not dissolve in excess sodium hydroxide solution. The formula of the transition metal cation in X. So what are you saying
Yeah.
for this
So
one?
Cu2 plus.
Cu2 plus, right?
Yes.
Okay, so this is Cu2 plus. Okay, and then what about the next one?
Pale blue plus precipitate and then dark blue precipitate.
Pale blue precipitate and then dark blue precipitate. Uh, Followed by an excess after adding a few drops of dilute ammonia solution. So first we were getting pale blue precipitate, right?
Hmm.
Pale
Yes.
blue precipitates, and then after adding excess ammonia, so we are getting dark blue, right?
Hmm.
Dark blue precipitate or a dark blue solution?
Precipitate.
Dark blue solution because the precipitate will be dissolving in excess ammonia. That's why we are getting deep or the dark blue solution.
Ah, yeah.
Okay. Yeah, because first of all the precipitates are formed and in another step the precipitates are going to be dissolved in an excess. So we are getting deep
Yeah.
blue solution. Yeah. So this confirms the inputs made in part one. Yeah. This is the confirmatory test for the part one. Or and then
Then after that, it's a yellow solution and CuCl4 2 minus.
because we are adding few drops of concentrated hydrochloric acid and the color of the mixture observed. So you are saying that first of all we would be getting
Yellow
yellow
solution.
color, right? Solution or a precipitate?
Ah, yeah, yellow color. Solution
Yellow solution. Yeah.
because it's
The color seen is caused
CuCl4 2
by
minus.
a species with the formula,
CuCl4 2 minus.
yeah, chloride. To 1 cm cube of X in a test tube, add a few drops of potassium iodide solution. Iodide means it's going to lose its electrons, so it is getting oxidized. So it's a reducing agent. Okay, so it's a reducing agent. First of all, potassium iodide is a reducing is a reducing agent. Okay, or then add a few drops of starch solution, a brown solution and a white solid form. The brown solution turns blue black. Identify by name or formula the substance causing the brown color and the white solid. So first of all we got the brown color,
Mhm.
so it's due to the iodine, of course, isn't it? It's due to the iodine. And then they are saying the white solid, and then they are saying the white solid
Is that due to starch?
due to starch. Starch is a solution. They are talking about the white solid. And remember, it's a reducing agent. So in the formula, the copper is +2. And after getting reduced, because Ki would be reducing copper 2 plus into, of course, reducing
Hmm.
agent reduces the charge. So initially I have copper +2. After reduction, it would be getting +2 to +1,
Mm.
isn't it? +2 to
Yeah.
+1. It's gonna be
Yeah. Yeah.
copper +1. It is getting reduced. It's gonna be copper +1. So copper +1
The
means
white
that,
solid. Yeah.
yeah, copper would be reacting with iodine, of course, because we
White
are going
solid.
to react with iodine. Copper iodide is formed. It's a white solid and the brown color is due to iodine. Because
Okay. So
potassium
I got what
iodide,
you're saying,
that is
but
Ki, when it is getting oxidized, it would be changing into I. As we know that this is the diatomic one, so it has to be like that. So the brown color is due to iodine. Okay, that's why.
hmm.
And then a reagent containing a compound of M produces the second oxide of M when it is joined with ethanol. That's an aldehyde. Name a reagent which reacts with ethanol to produce this second oxide of M. What is M? Our transition metal M
Mm.
has two oxides. Okay, so the one oxide that we have solved, then we are going to work on the second oxide. A reagent containing a compound of M produces the second oxide of M when it is bound with ethanol. So name a reagent which reacts with ethanol to produce this second oxide of M. Ethanol is an aldehyde, so it is going to be um, what can I say? Um, it is going to be
Secondary.
oxidized by some oxidizing agent. So we are supposed to use
Yeah.
Benedict solution, Fehling solution. Okay, we can say
Okay.
Benedict
This this
solution or a Fehling
contains a
solution.
compound of M, produces second oxide of M when it is bound with ethanol. Name a reagent which reacts with ethanol to produce. Can we say potassium dichromate?
Potassium dichromate. No. Is this an alcohol? No.
No.
Yeah, for an alcohol, we generally use potassium dichromate. For an alkene, we generally use KMNO4. And for the aldehyde specifically, we can use Benedict solution. If you remember, we used to say Fehling solution.
Mm-hmm.
That's a mild oxidizing agent. It's not a strong oxidizing agent. So a reagent containing a
Just yeah.
compound of M produces the second oxide of M when it is bound with ethanol. So I can say it's a Fehling solution. Then they are asking about the formula. Then they are asking about the formula. Give the
This
formula
one
of this
Cu2O.
second oxide of M. Exactly. It would be
Cu2O.
Cu2O. Yeah, because Fehling solution is the ammonical solution of no, copper sulfate plus it's an alkaline solution of copper sulfate. So copper plus 2 would be changing into copper plus 1 because it is getting reduced. It's an oxidizing agent. Oxidizing agent is the one which oxidizes other and reduces itself. So initially in a Fehling solution, the copper sulfate, copper was plus 2, and after getting reduced, it's changing into copper plus 1. That's why we are looking this copper cuprous oxide, in which if you will be finding out the charge of the copper, so you will see 2 copper plus oxygen is equal to 0 and copper would be equal to plus 1. That's the charge of
Hmm.
copper in this oxide. So that's why it is getting reduced.
Yeah.
Describe what you would see when carrying out this reaction.
Formation of brown precipitate.
Exactly, from the blue solution, right?
Yes.
Yeah. So it's not pure brown precipitate. It's not pure brown
Reddish
precipitate.
brown.
We can say reddish brown precipitate. So blue solution, that was the original color. Blue solution to reddish brown precipitate. Blue solution to reddish brown precipitate.
Yeah.
This question is about butanoic acid and one of its isomers. State what test you could use other than adding an indicator or using a pH meter. That's an acid. Okay. To
React
confirm
with
that butanoic acid
PCl5.
contains an acid group.
Oh, acid group. Sorry,
PCl5.
sorry, sorry. Sorry, that's no. I thought my bad. One second. One second. The question is about the reaction about butanoic acid and one of its isomers. State what test you would use other than adding an indicator using a pH meter to confirm that butanoic acid is present. Let's react with so with sodium carbonate, effervescence is observed and CO2 is released, right? Making KOH milky white, right?
We cannot add sodium metal. We cannot add
No, sodium
PCl5.
carbonate. Sodium
Yeah,
carbonate.
sodium carbonate. Because sodium carbonate would not be reacting with an alcohol. Alcohol is a very weak acid. So if we will be adding sodium carbonate, so we would be getting an observation that would be fizzing, effervescence, bubbles
Yeah.
of carbon dioxide. Yeah.
Yes,
So
like that.
add add sodium carbonate. Add sodium carbonate so to that solution to the sample. So as a result we will see effervescence. As a result we will
Yes.
see effervescence of a colorless gas, right? Effervescence of a
Hmm.
colorless gas, that is carbon dioxide. Effervescence colorless gas, that is carbon dioxide. Compound A, that is compound A, okay, is an organic liquid which is an isomer of butanoic acid. Okay, means that it's a carboxylic
Hmm.
acid. There are two functional groups in A. Neither functional group is a carboxylic acid. Oh, okay. It may be ester, isn't it? Because the
Yes,
isomer
it can
of
be
the
alcohol
functional
also.
group isomer of uh, the the functional group isomer of carboxylic acid is an ester. Is an ester. So tests were carried out
Yes.
on A. Dry phosphorus chloride was added to A. Steamy fumes were produced. So means that this is an alcohol because it's going to react with PCl5. Steamy fumes were produced which turned damp blue litmus paper red. State what you can deduce about A from this test. So we can say that
Consists of an OH
exactly.
group.
Exactly. That's why it's going to release fumes, steamy fumes of we can say HCl, right?
Yeah.
So what you can deduce about A from that test. So
This
A
thing.
contains OH,
OH, yeah.
OH group.
Yeah.
A was tested with 2,4-DNPH solution. Okay, the solution, the result was positive. State what you would see when a positive result is obtained in this test and what you would deduce from this test. Observation.
Orange
So when
precipitate, and this is
2,4-DNPH reacts, yeah, exactly. When
due to carbonyl
2,4-DNPH
group.
due to carbonyl group. Okay, so observation is orange solid. Yeah.
Orange precipitate, yeah.
Orange precipitate. Deduction contain which group?
Um, which the
Carbonyl
deduction
group,
is
right?
contains carbonyl group. Yes.
Another portion of A was then burned with Tholin's reagent. No change was seen. What you can deduce about A from this test?
It is not an aldehyde.
It's not an aldehyde. And 4 was A was born with iodine. A was born with iodine in the presence of sodium hydroxide. Pale yellow crystals formed. It's an iodoform test, right? What you can deduce about A from this test? If you
Consists
remember, this test was
consists of methyl
applicable
ketone.
for
Yeah,
methyl
methyl
ketone.
ketone.
Exactly, exactly. Because we got a positive test for 2,4-DNPH. So of course it shouldn't be an alcohol, right?
Yes.
Methyl ketone is CH3CHO.
Okay. Next. A is optically active. The carbon chain in A is not branched. Draw the displayed formula for A and which is consistent with this information and deductions from BI and B4. BI and B4, BI and B4. So they want us to draw, right? Draw the displayed formula of A. BI, BI consists of an OH group.
The carbon chain in A is not.
Neither functional group. Okay, so it's not carboxylic acid. It consists of an OH group and it has a methyl ketone also. So if it is a methyl ketone, first we draw that. Okay, so one, two, three, four. Four. Um, there are four carbons.
Last time. What did you listen last time? What did you listen last time?
Yeah.
I told you a lot of things. The call was disconnected. Mhm.
No, no, no. I only listened until um this thing. Ah, so until where you drew, but I didn't
Oh
hear
my
about the
God.
chiral symbol.
Okay. 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 Basically, uh, they are saying that you have to see from B part 1 to B part 4. So basically in part 1, we have identified that it's going to have OH group, and in part 2 we have identified it's going to have a carbonyl group, and in the
Yeah.
third one we have identified it's not an aldehyde. Of
Yeah.
course, it must have a ketone, but what type of ketone it has? In part 4 we have identified that it has a methyl ketone. So,
Yeah.
and in the part 5 they are saying that it's going to have a chiral center. Chiral center is the one which is by which there are four different groups attached. Singly bonded, it must have a single covalent bond. So then,
Yeah.
after these deductions, I have identified the structure. It must have a methyl ketone, it must have an alcohol. So, if you are thinking that, why did you write OH on the second carbon atom? Why not on the first carbon atom? So the thing is that if I would be writing on the first carbon atom, so then there would not be any chiral center. Then it's gonna be H. There is no chiral center. To make
Hmm.
it chiral center, I have
Yeah.
to draw OH on the second carbon atom. Then everything is fine with this structure, and and of course that's the isomer of butanoic acid. So we knew that it must have four carbon atoms. So that's the structure for this one. This was A.
Yeah.
State why the low resolution proton NMR spectrum of A has four peaks. Yeah, this one they're talking about this one, right? Why it has
Yes,
four
I
peaks.
told that because there are four different proton environments.
Yeah, so I can say first of all, this one, then this one, then this one, and then this one, because I'm looking at only the proton, right?
Yeah.
Yeah.
And
So
and then state the number of singlets, doublets, triplets, and quartets. So first of all, one. So okay, this will be
number of singlets.
triplet.
Okay, I think it has one singlet, isn't it? Because I would be getting the singlet for this one because there is no neighboring hydrogen with this one. So I would be getting only one singlet. And then they are saying that how many doublets I would be getting. So no, I can get the singlet for the OH as well, isn't it? For the OH
Yeah,
as well.
because it's
Yeah, I can get the singlet for the OH as well. So I have two singlets. And if I would be looking at this CH3, so there is only one neighboring hydrogen atom. So when I would be applying the formula, that is n plus 1, of course that's going to be 1 plus 1. So I would be getting only one doublet. One doublet I have. There is no triplet. There is no triplet. For the
yeah.
triplet, I must have the two neighboring hydrogens. There is no two neighboring hydrogen. And if I would be looking at this hydrogen atom, on its right hand side, we have three protons. So n plus 1 means that it's going to be 3 plus 1, that would be 4. So I would be getting one quartet, isn't it?
Yeah, one quartet. Um, uh, yeah, one quartet, one single. So one single, one single. Um, uh, isn't it one? No, two singlets, one
Okay.
quartet,
Hmm.
zero triplets,
Yep,
and zero
that's it.
doublets.
Yeah. No, one doublet.
Where is the one
Doublet
doublet?
for this one. Doublet for these three hydrogens have one neighboring hydrogen atom.
Ah, sorry. Yeah, yeah, yeah. That's yeah, yeah. One second. Okay, next. Ethyl ethanoate was hydrolyzed by reacting with HCl. 10 centimeter cube of the ester and 10 centimeter cube of hydrochloric acid were placed in separate containers with water bath at 40 degrees Celsius. Content allowed to reach a temperature at the water bath. The ester was mixed with the hydrochloric acid and the timer was started. At intervals over a period of 60 minutes, 1 centimeter cube sample of the mixture were withdrawn by pipette and added to a mixture of ice and water in a conical flask. These samples were then titrated with 0.2 mole per decimeter cube of sodium hydroxide solution aluminum burette. After 60 minutes, the remaining mixture was heated under reflux for 15 minutes. Another 5 centimeter cube sample was then withdrawn and the titration repeated. Um Write down the equation for the hydrolysis of ethyl ethanoate. State symbols are not required. Okay. C H E C O O C. So ethyl
Hydrolysis means the reaction
ethanoate.
with water, isn't it?
Yes.
So when it would be reacting with water, of course, this is an ester. After hydrolyzing this ester, we would be getting carboxylic acid and an
Carboxylic
alcohol. So
acid
the
and alcohol.
carboxylic acid would be ethanoic acid and alcohol would be ethanol. This
Ethyl will
portion would be
always
giving
be the
you alcohol and
alcohol.
this would be
Yeah.
carboxylic.
So C2H5OH plus C CH3COOH, right?
Yeah.
Yeah. Next. Explain why the number of moles of hydrochloric acid in each 5 centimeter cube sample remains constant.
Uh, 10 blah, blah, blah. Okay, okay. Hydrochloric acid were placed in separate containers in water bath. The contents were allowed to reach the temperature. The ester was mixed with the hydrochloric acid and a timer was started at intervals over a period of 60 minutes. Okay, 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 okay. And hydrochloric acid, they were titrated with sodium hydroxide. After 60 minutes, the remaining mixture was heated under reflux for 15 minutes. Okay. Explain why the number of moles of HCl in each 5 cm cube sample remains constant.
Um,
In a in an aster, if you remember, we were making an aster by the reaction of carboxylic acid and an alcohol by the addition
yeah.
of acid that was used as a catalyst. And catalyst
Yeah.
doesn't used up in a chemical reaction. It's only going to speed up the reaction. That's why. So what am I supposed to write in this one? I can say acid is a
HCl acts as a
catalyst.
catalyst.
Exactly. Acid acts as a acid acts as a catalyst. Yes. Give a reason why the samples were added to a mixture of ice and water. Because yeah. What's the reason?
Why were the samples like bit tighter? Mm. And added to a mixture of ice and water in a conical flask so that the to quench the reaction.
Why?
Mm, I think. Because then I just know that you have to quench the reaction. That's why.
Basically, you are going to do titration. and the reaction is going on continuously. You are supposed to check that how much HCl has been used. That's why you are going to, like, basically you are going to titrate a sample with sodium hydroxide. And when
Yeah.
you will be titrating the sample, and in the back the reaction was also going, so
Mm.
then it would be very difficult to check. It would be very difficult to look at the reaction, to look at the reactants, how much things are used up, how much things are going to be formed. So when you will be doing your titration, I don't want to have the continuous reaction. I want to see that the reaction should stop while
Yeah.
I was doing titration. Once the titration is done, then it's on my hand, then the reaction should start, and then the product would be forming uh, accordingly. So that's why when I would be doing the titration, the reaction should be stopped. So basically, that's why we are going to add the reaction mixture in an ice bath to make the reaction slower, or you are saying that the to quench the reaction. That's why. Okay,
Yeah.
that's the reason.
The mixture. Yeah.
You're supposed to write it in
Yeah.
detail so that you may know, because a lot of time you would be asking the same question.
Yeah. Phenolphthalein, this is colorless to pink, so it's okay. Next. The mixture remaining after 60 minutes is heated under reflux, and another 5 centimeter cube sample is titrated. By considering the products of the reaction,
By the way, phenolphthalein is banned because it's a carcinogenic. Then generally we
oh,
use methyl orange. E part one. This is an old paper, right? That's why.
okay. Why did they even change the specification in the first place?
Why did they what?
Why did they even change the specification in the first place? Like, this is old spec, right?
₹1,500
Think
kilo.
you're mute. I think you're
After
muted.
10%. Now can you hear me?
Hello? Yeah, I can hear you now.
Yeah. What about E part one?
Let me think. By considering the products of the reaction, the mixture. Okay. Product of the reaction. Okay. Amount of yeah. Amount of a volume of uh, HCl required to neutralize NaOH. I don't know. I'm not sure about this.
The mixture remaining after 60 minutes heated under reflux, and another 5 cm cube sample was titrated
Yeah.
after 60 minutes. By considering the products of the reaction suggest what information this titer provides. Whether, because as a result of this, you can see initially we have aster. It's going to be hydrolyzed. Of course, by the end of this reaction, all the ester will be hydrolyzed, and it's going to produce carboxylic acid as a product and an alcohol. That's why
Yeah.
we are titrating carboxylic acid. So, um, by considering the products of the reaction suggest what information this titer provides, whether all the ester has been hydrolyzed or not. whether all
Okay.
the acid has been hydrolyzed or not.
So
And also, it's going to tell you about the total number of moles of acids that would be forming as a result of the product in the form of carboxylic acid, of course.
yeah. Now next. Draw the label diagram of the apparatus used to heat the reaction mixture under reflux. Okay.
Continuously, it's the third paper in which they are asking the same diagram.
Yeah.
Okay.
I'm drawing it.
The results of the experiment are shown. Results are this one. The quantity V. The quantity V is directly
Sir,
proportional to the
one second,
constant.
one second. I'm drawing the diagram.
Okay, 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 okay.
Anti-bumping granules. Uh, water. Uh, water in, water out. In,
This is a
out.
pear-shaped flask which is connected with the condenser in which there is a water in and a water out to make the walls of the condenser cooled so that your gas can condense to the liquid form and the gas, uh, like I can say, to stop these vapors to go to the environment, to escape, to prevent the loss of a liquid from the pear-shaped flask. That's why we are going to use the condenser.
Yeah, got it. Now, the results of the experiment are shown. Results. The quantity V, okay, the relative proportion to the concentration of ester in the sample. Plotted with graph.
Okay, 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 okay. Oh my God, it's of 2 marks.
I'll
It
plot
should
it
be of
quickly.
6 marks. Okay.
Yeah, but no, like even now it's only 2, 3 marks. Even
Yeah.
now,
Oh my God. One, two, three,
I
four, five, six, seven. 7 points. So you have to. Okay.
will plot it quickly.
Will you be drawing this one, or I'm supposed to draw it?
No, I'm drawing it so that I have the values.
Okay.
Okay, now what are they asking? The question is axis against V against time. Okay. V against time. Now, what is the time? 0,
The total
10,
time
30,
is
40,
60.
60. Okay.
Yep, the total time is
10,
60.
20, 30, 40, 50, 60. Okay.
This is 10, this is
60,
20, this
50,
is 30, this is 40,
40,
this is 50, and this is 60.
50,
Yep.
20.
Okay, now the total values are from 22.70 to 41.20. Yep.
From where? 0 to 25, let's say. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, fine. Yeah, that's good. Okay. 2,
So I can
2,
say that it's 0,
4, 6,
4,
8, 10, 12, 14, 16, 18,
24.
20, 22, 24. Okay. Now,
They have given us
now
the
the clock.
values in a centimeter cube, right?
0 is 22.3. 0 is 22.3. So, wait, 2 divided by 5 is 0.4, 22.3. So, it is a little bit big. Hmm. Then 10 is 16.5.
22.3.
16.5.
0, 22.3. It's gonna be 1, 20.2,
10 is 12.5. 10.
22.4,
Correct, correct.
6.
Then what is it?
And
30 is
then
9. Okay.
10, 16.5.
8.1, wait, 8, 0.4, 8.8, 9 point.
And then 20,
What is 9
12.5.
times 8?
12.5.
40,
20, 12.5, 39.05. Okay. 30 is 9.05. This
7.1,
is 8.4, 8.8.
6, 6.4, 6.8, 7.2, 7.8.
Okay, 7.1.
1.
7.1.
50 is 5.25.
6.4.8.
Yeah, this is definitely looks like first order. 60 is 3.8. 3.8, 3.8, 3.8, 3.8.
47.1.
50,
Yeah, 55.25.
2.4,
50,
2.8, 3.2, 3.6,
4.8,
3.8. Yeah.
4.4, 4.8. 55.25, 63.8. 60, 63.8. Okay, 2.4. Yeah, that's it.
Okay. Now, use the graph to determine the order of reaction by measuring two successive half-lives. One half-life
0
is
to
half of
22.3.
22.3 divided by 2.
22.3 is this one.
11.15 is the
So
first
it should
half-life. 11.15. So 11,
be
10.4, 10.8, 11.15 is almost 11.2.
the first half life.
Yeah,
So the half of 22.3 is what?
11.15. It's not the
11.15.
half-life. I
It's
mean, it's
gonna be
the
12.
half of the constant.
Yeah.
Then the second half-life, this one divided by 2, 5.6, 5.7, 5.75, 4.4826. Yeah. Okay, now let's see. First half-life, second half-life. Now 26.
So the half of 11.1 is 11.15 is 6, no, 5 point something, I think so.
No, I'm telling the first half-life I found. First half-life is 26,
Okay, the
almost
first
20,
half life is 26.
and the second half-life is 48 minus 26. 48 minus 26 is 22. Order of reaction hence is um first order.
So then we have to see if the two half lives are same. So it's mean that it's gonna be first order, right?
Yeah, they're approximately the same.
Yeah, exactly.
1 second.
Okay, okay. Calculate the number of moles of ethyl ethanoate in the 10 gm cubes used in the reaction. Make sure data for ethyl ethanoate is this one. Okay. They have given you the density and the molar mass. So what am I supposed to do?
Calculate the moles of
0.900
ethyl
grams
ethanoate.
multiplied by
Moles. Okay.
88.1 grams per mole. So I'm supposed to divide it, I think so. No?
Wait one
No, no, no,
second.
no, no,
You
no, no,
divide
no, no,
that.
no, no. I did the wrong one. No, no,
Yeah, you have
no.
to do
I was thinking that the
0.9
units
over
would be cancelled.
88.1. That'll give the
Uh,
concentration.
but but the thing is that they are asking concentration? No, they are asking the moles.
No, concentration times the volume gives the moles, right? So
Yeah, so
if
where
the
is the
density,
concentration?
so no, so my point is now they're given the density in grams per centimeter cube. So because the density is unit is grams per centimeter and then over grams per mole, and then so when you cancel if it's mole over -1 in the bottom, it'll become mole
Yeah,
uh
I can.
10 centimeter is
What if I'm going to find out the mass first? Mass of
one.
ethyl ethanoate that is equal to 10.0 centimeter cube multiplied by 0.9 grams per centimeter cube. It's gonna be cancel. So it's gonna be 9.0 grams, isn't it? This is the mass of ethyl
Hmm.
ethanoate, right?
Yeah.
And then once I got the mass, then I can get the number of moles. It's gonna be 9.0 divided by 88.1. This is the molar mass. Then I would be getting the moles of ethyl ethanoate. What's the answer for this one?
Yeah. I got the final answer as 1.022 times 10 raised to
-1.022
-4.
negative, huh?
Times
Negative
10 raised to
4.
-4. Yes.
9 over 88.1. No, 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 no.
Oh wait,
It's
I
not
no no
10
no
to the
sorry
power
sorry I didn't
minus
do
4.
no. I yeah, my bad. I know where I went wrong. 9. Yeah. It was 1 second. Okay. Times 0.01. 1.02 times 10 raised to negative 1,
-1
right?
mole. Yes. Give a reason why the number of moles of water present for hydrolysis doesn't have to be known when finding the order of reaction.
Wait. Give a reason why the number of moles of water is in excess. Water is in excess. So concentration remains almost constant, hence having no effect in the order reaction, right?
Yeah, basically, when we are going to hydrolyze something else in the presence of water, so we have to take water is in excess because the role of
Yeah.
the water is to hydrolyze the substance. And also from the Kc and Kp, if you remember, we used to write the Kc expression, and if there is some water, so we were not supposed to add that water in a Kc expression. The reason was that the concentration of water doesn't change. So the same reason for that, if the concentration of the water is not going to change, so that's why we are not supposed to include it in the order of reaction because the concentration is not changing. So
Yep.
concentration of water change.
Now, the student suggested that the order of the reaction could be found by plotting a graph of pH of the mixture against time and measuring half-life. Give two reasons why this method cannot be used. Uh, give two reasons why this. Okay, so
It's very clear from the graph. They have told you initially, if you remember, they were saying that
so this is
V
not
is
directly
directly
proportional. This
yeah,
is not directly.
exactly. If you know the formula, that was pH is equal to the negative log of the concentration of H positive ion. Negative log means it's inversely proportional. It's not directly proportional. And what's the other reason?
Um, not sure.
Remember, if you will be plotting the graph on the basis of pH, so the pH doesn't change. Like you can say drastically, the change in pH would be very small. The change in pH would be very small. If this is very small, so we would not be able to draw the curve. And if we will not be able to draw the curve, so of course indirectly we would not be able to find out the order of reaction. Okay, so
Yeah.
first of all, I can write that pH is not directly proportional to the order of reaction. pH is not directly proportional. pH is not directly proportional to the acid concentration, and change in pH is very small, difficult to draw the curve. The question is about the preparation of 4-phenol. 4 phenol, oh sorry, 4 nitrobenzenoic acid from 1 methyl 4 nitrobenzene. Okay, okay, okay. State the meaning of each symbol. Okay.
Oxidizing, corrosive, and toxic.
It's an oxidizing
Right?
agent. Okay. Like oxidant, I can say. Or it's a corrosive. Then toxic.
Oxidizing, corrosive, and toxic. Yeah.
Showing the apparatus used to filter under reduced pressure. Oh my god, again the same thing. We have to write down the suction pump, isn't it? If you remember in the last paper.
Yeah. I'll I'll draw this.
Like that.
Yeah.
25 by name or formula, the solid chromium 3 compound
One
formed
second,
in
one
step
second,
3
second,
and
I'm drawing.
states color.
Yeah, yeah, just drop one second. Filter, paper, Buckner, funnel, steel, side, arm, to vacuum, uh, to vacuum pump. Identify by name, color, or formula the solid chromium compound formed in step 3 and state its color. What is step 3?
Step 3,
Step
what's
3.
going on in
Transfer
step
the
3?
sol
Transfer
okay
the solid.
into a beaker.
Add
Add
enough
enough
sodium
sodium
hydroxide.
hydroxide, so
Yeah,
excess.
exactly.
Before filter under reduced pressure to remove the chromium 3 compound. Collect the filtrate. Okay. So when it is excess um OH, first of all, it's chromium. Color will be green. Um, now the solid, so it has to solid means that it doesn't eh, no, but it is also an excess OH. Wait, filter enough. Okay, so this is just enough, not excess.
Yeah,
So
exactly. So
CrH2O
when we were adding in iron, so iron
B
was producing iron hydroxide. When we were adding in copper, it was forming copper hydroxide. When we are adding in chromium, it would be forming chromium hydroxide.
yeah.
It would be forming
So
chromium
it's
hydroxide. So I'm supposed to write
CrH2O3 OH3 whole raised to 3 plus. Next, give a test and a positive result that will
and what's
show
the
the
color?
solution of
Green
4
color, right?
green. Yes,
Green
green.
color. Yeah, exactly.
Yeah.
Uh,
4
okay.
nitrobenzoic acid in step 4 is highly acidic. Dip a litmus paper and
Litmus paper will
no,
be
universal
only telling
indicator.
you the
Universal
presence of,
indicator.
yeah, exactly.
Universal indicator.
What
Use
if I would be adding a
a
pH meter?
it'll be really high. Really low, sorry. Right?
What if I would be adding a pH meter? Is that right?
Oh no, no,
If
because it's highly acidic, right? Right?
yeah, so after you can add universal indicator. You can also dip the pH meter, and if the pH is lower than 3, if the pH is less than 3, so yes, I can say that this is going to be strong acid. Or
Yeah.
strong acid. So in the presence of a strong acid, the color of the universal indicator would be changing into red.
Yeah.
Yes.
Now, next question.
Use
Benzocaine can
BH.
be prepared from 4-nitrobenzoic acid by carrying out two further reactions. Benzocaine can be prepared from 4-nitrobenzoic acid. Calculate the mass of 4-nitrobenzoic acid that is required to prepare 10 gram of benzocaine. The yield in each of the two further reactions is 70%. Okay, 10 grams. So, is there an equation?
So 3 marks. Giving us the mass of that is required to prepare 10 gram. The yield in each of the two for the reactions is 70%.
Yeah, so first what we need to do is we need to find the moles. So N is equal to M over MR, which is equal to 10 over 165. What is 10 over 165? 10 over 165. 0.0606. Okay. Now, what was it formed from? It was formed from benzocaine, 4-nitrobenzoic acid. Okay. 4-nitrobenzoic
Okay,
acid. Okay.
that's the mass. That's the mole
So then,
basically.
yeah, so then after that, you
Oh,
have to, so you know that there are two further reactions and yield in each of them was 70%. So 70% of something is 0.06. So 70% of something
of
is
0.0606
of x is
multiplied by
0.0606.
70%.
And then wait, so something multiplied by that gives this. So that is, and then again you have to end up doing it. So like y times x.
In each of the two
Okay,
further
so
reactions, right? So we have to multiply it by twice.
uh,
Twice. 70 twice.
yeah, 1 second, 1 second. 0.06060 divided by 0.7. Okay, 0.8. 0.12367555102. So n is equal to m over mr. M is equal to n times mr. mr is equal to mr is equal to mr is equal to mr is equal to how much is the mr? Mr is 167.
Once. So what's the answer for this one to get the moles after 70%?
20. The moles is 0.12367555102, and then after that the mass of this one needed will be 20.65, right? Grams.
And what's the mole ratio?
Mole ratio, they didn't mention, I think.
Okay.
Yeah, they didn't mention. There's no mention. So it must be 1:1.
So that would be the moles of 4-nitrobenzenoic acid, the same thing, right? And that's the
Hmm.
mole. So if I would be getting the mass, what's the MR of benzenoic acid? Nitrobenzenoic acid. Nitrobenzenoic acid is this one. Yeah, 167. Okay. It's 167 times this one. So I would be getting the mass. That is the answer.
This it was 20.65.
grams. Okay. Okay, that's all for this paper.